Hi and welcome back to the Refinitiv Developer Community for part 6 of our tutorial looking into our article estimating USA GDP via an expenditure approach in the Holt Winters model. Up to now we've had a look at how we may use all of this method with positive data, but now we're going to be implementing it with negative data and we're going to try and plot some graphs to have a look at what we've got this far. So without further ado, let's get to it. All right, so to delineate between the work we've done this far and the one we're going to be going ahead with, let's use some Markdown. I'm going to click on the left here just underneath the number and press on B to create a new cell. And here I'm going to go for Markdown to delineate just as I said. Okay, going forward then what we're going to be doing is using the exact same method we've done before with the model fit object. And we're going to be using the net export data from our data frame we called DF. You'll recall that the net export data sometimes goes negative because we may import more than we may export, and we're going to be again removing the not a values within our data frame DF, and we have our yearly seasonal trend, our additive trend that we're looking at, and we're damping our model here, and we're finally fitting it. Okay, running this then, you see that it doesn't work, and the reason is because the data must be positive. This is a peculiarity to do with the mathematics behind the Holt Winters method. And so as a result, what we're going to do is we're going to move our data from the negative realm to the positive realm in order to then fit our model and then push it back to where it should be. Okay, to do so, what we're going to do is that we're going to try and find the lowest value that we have within our data frame, the one that is the most negative. To do so, we're going to do this here right now with this data minus P1. Now, the minus is there, or the minimum is there, because we're looking for the minimum value within our data frame, and we're going to do the absolute of this, and we're going to have also add 1 to it. The reason is because I just want to go one step ahead, add 1 to it to make sure that it's all positive. So here you see we're using this .min function to find out the minimum within our data set, and we're going to create this data min plus 1 object. Of that object, we're then going to add the series of numbers from our data set. We need this .copy here just because of a peculiarity to do with pandas data frames, and we're going to drop our NANs to then have a look at our only positive data for our net exports. You can see here we're adding to our data frame df1 this net export value that is only positive. Okay, let's run this and we can have a look at df1 and see that we've got here our net exports monthly step data that is only positive. We've added to this the minimum value within our data frame, but it's the absolute value of it, and we've also added 1 to it just to make sure it's definitely within the positive realm and it doesn't even touch 0. Okay, moving forward then what we're going to do is we're going to be using the Holt Winters model we've been using this far with this positive only data, and we see here that we've got the data that we've created before. Let's run this. Don't worry too much about the errors that may occur, apart from if they're actually stopping your code, and here we can have a look at the fitted values just as we've done before. You can see here that we've actually got fitted values. It seems to have been working. And so what we can do as a result is we can then add to our df1 function everything that we've done this far, going from our fitted values, monthly step data, in the exact same method we've done before, but this time we're going to be adding, or rather subtracting, this data minimum plus 1 that we've removed from the very start in order to then calibrate it back to where it should be. We're going to be doing the same for our forecasts here, and then have a look at the difference between fitted values and the forecasts in the fitted values. So let's run this and have a look at df1. You can see here that we've got all the data as we expected, and we can actually then go ahead with our graphing of the data we've got this far. Let's use some Markdown to delineate between the two steps, and now let's have a look at our forecasts. We're going to have a look at all of the summands of our GDP. So first of all, let's have a look at our investment forecasts. We've got them right here, and what we can do is then try and plot all of the data, including the forecasts. Now, it's going to be a bit long, but I'll go through it with you. First of all, we're going to be creating these two objects in the similar fashion that we've done before, specifying the size of the plot that we want, the face color, and that we're going to use the investment data that we've got this far with our plot. And I'm using this style, this dash style, just to show you how things would look different if I used different styles. Let's color it in blue and have a legend for it with a legend of our investment data. We're going to be doing the same for our fitted values from the Holt Winters model, and then the same for the forecasts. Let's put the forecasts in green like that, and then set our face colors exactly in the same way we've done before. Okay, let's run this. You can see that we have our investment data in blue, our model fit in yellow, and just there, I don't know if you can see it, in green is the 3 time period forecasts, so the next 3 months forecast. So we can see that it's actually forecasting to go slightly up and to go back towards the trend that we've had before COVID. You can see here this was the COVID dip. So what we can try and do instead of going through all of these steps every time is we can create a function to plot this graph every time we have an Holt Winters model fit. We can create this function with a specific name, a forecast period of our choosing, as well as many other arguments of your choosing that I've described right here. You can have a look at it yourself in your spare time in the article if you want, but I'll just go through certain things that we're going through here. For example, we're using global df, which means that it's using a data frame called df that was created before the function. So if you are using this function, you may want to have a data frame called df before you use it. Here we are accounting for negative values just as we've done before with this technique of data minimum +1, and we are accounting for the fact that we may have these negative values or we may not. This is what this if statement is there for. We are also silencing the warnings because sometimes we could see some warnings coming up. You may try to have that or ignore it with this argument right here, the silence warnings. And then finally we are fitting our model exactly as we've done before creating columns into our data frame called df for our fitted values, our forecasts, and the real errors. Finally, we're going to be plotting all the data in a similar way that we've done before. Running this function in memory, and we can use it for any of our summands. So for example, let's do it for our investment. You can see right here we've got our forecasts printed out, and we have our graph. We can also try and have a look at the statistics behind the data that we've got here this far using this statistics table function that we've created before. You see what we've done. We're using the statistics table and we are adding it to a pandas data frame and only looking at the data that we're looking for specifically. So here it's the investment forecast and the fitted values that I'm interested in, and specifically also the mean of absolute values. This is a statistics that I like to have a look at. You may try to have a look at any of the ones that we've created within the statistics table itself. Let's run this and we can see the data that we've required, and you can do so for any other summand that you may be interested in. Okay, let's do the same thing then for our government investment, and you can see again that it's working fine, but unfortunately due to the nature of the negative values within the Holt Winters model, I've done it so that it doesn't actually plot a graph if you were to go with negative accounting method within our function. Okay, this is a quick one which went through just how we may graph the data that we've gone through this far using negative values within our Holt Winters model. I hope you enjoyed everything this far, and in the next part is going to be quite a big one. It's going to be part 7, looking at backtesting our method and looking at how well it would have done were we to have used this method on a one step ahead basis. All right, I hope to see you there.